leader. Define phase. What is your main objective? Come on, all of you.
For it to start is actually, yeah, the bars how you calculate on individual factors and its frequency. Some almost it's like 80% of defects are due to 20% of causes. You should focus on those 20% causes, why that cause has happened. Okay, and you should be open to your customers, like what opinions they have, and then finalize it and uh, calculate actually the cost of how poor that quality of your product is. Okay? And eventually, one by one, then you need to reduce that frequency of that cause. Okay, so eventually, those defects will be minimized. And secondly, if you are on a scale of 10, then only 2% chance of this thing has to be given to your competitor.
All right. So
All
others,
data should be like calculated. All data should be maintained on this.
very good. Fantastic, fantastic. You have recollected the important points. How about others? You were also active, right? The first session. So you can contribute, all of you.
So at define phase as a project leader, I would like to make the voice of customer as well as that voice of business. Means
Fantastic.
what is the pain areas that may be defect, that may be business related, any kind of concerns, challenges. So that would be my first priority as a leader to record all these things.
Understand. So you will listen to the voice of the customer, voice of the business. Either if they are available in the form of some data, or you can even directly go for a brainstorming session.
Yeah.
You can interact with them, or you can give them an opportunity to, represent their problem, and definitely you will be flooded with, the opportunities for improvement. Okay. How about others? Do you like to add anything if they have missed any important point?
Yes, we can use some data while defining a problem, like market complaints and all those customer feedback, as someone has already mentioned. So those data can be considered defining a problem.
Very good. So the available data can also be used to describe your problem, right? Very good. Anything else?
First, sir, we have to prioritize the problems, and then we have to solve the problems like in 80-20 basis. Like first 80% of the problems we have to solve, and then um, followed by the other problems. So like that, we have to prioritize what are the problems are, and we have to carry it on. And then like in that problems also, we have to classify it, like it is top defects, and then level 1, level 2, like that we have to classify it, and then we have to solve it off by using Pareto chart. And then we have to made a charter also for that, and we have to approve this from the management side, so that we can work in that project for a particular time period.
Very important. Very important. Yeah, correct. Okay. So what is very important is we need to create a project charter and get it approved. We need to create a project charter and get it approved. Am I audible?
Sir, your voice broke out.
Oh, voice is breaking. How is it? Is it better now?
Now it's better. Yeah.
Oh, it's better, right? Okay. So thank you so much for all the contributions. Anyway, I will quickly summarize my understanding about the define phase. So a problem well defined is half done. Agreed? A problem well defined is half done. So very, very important phase of the Six Sigma project is, defining the problem. You remember in the list of 7 habits, there was one important point. Listen to get listened. What is the meaning of it? seek first to understand. If you're trying to some problem first, no, you put all efforts to understand the problem thoroughly. All right. And how will you communicate to others that you have understood the problem? By identifying the right pain metric. By identifying the right pain metric. Even your customers, be it external or internal or end user, or be it your boss, you have to talk to them with the appropriate metric. They're really worried about one such metric. They're really worried about one such metric. You must try to understand that particular metric. Find out a metric, then write a definition for it. You should be able to write a definition, and then you should also be able to write a formula for it. And then you should be able to measure it with some unit of measurement. Clear, all of you? So what is very, very important? A pain metric, right? A pain metric. The pain metric is known as CTQ or CTB, critical to quality or critical to business. Critical to quality means customer dissatisfaction will certainly happen. So it's a top priority problem. Critical to business means it's a productivity issue, or it may be an issue related to quality also, and there is also a chance that issues related to productivity. You know what is productivity? How fast you are producing the products, or how fast you are offering the service. So you should be able to find out a metric, and just with one metric, you should be able to represent the whole problem. Just with one metric, you should be able to represent the whole problem. Suppose imagine in a BPO industry, let's say it's a data processing industry, right? So they know their concern is to meet the accuracy requirement of the customer. To meet the accuracy requirement of the customer. You know, in normally in such industries, they will be processing some kind of the data. Maybe it is in a form on an image format, and then they pick up the information from the image, and then they have to type it in a software. All of you understand? They have to pick up the content and then type it in a software. And now customer says, you have to give me 90% requirement. Sorry, you have to give me the data with the 90% accuracy. Now can one of you tell me, what is accuracy here? 90% accuracy. Customer requirement, customer simply says, I need the data with the 90% accuracy. And now, anybody here, will you be able to explain the meaning of 90% accuracy here? What is the customer requirement here?
The error percentage should be less than 10%.
Yes, the error in the data submitted by you should be less than 10%. Then only the accuracy is 90%. But in order to properly define the meaning of accuracy, what right now me and we are we're trying to explain is a general understanding about accuracy. If accuracy is 90%, then the error is 10%. Everybody knows. But then what is exactly the meaning of accuracy, the meaning of error with respect to the particular BPO industry? You have to read the contract. Yes or no? You
Yes.
have to read the contract. You need to understand how they actually calculate accuracy. There is no hard and fast rule to calculate the accuracy in a one particular manner only. No. They can have their own definition. Yes or no? Customer is a king in any business. He can define. In one of the BPO industry where we actually helped them improve on the accuracy through the same Lean and Six Sigma strategies. So their definition of accuracy goes like this. There is a document which contains about 35 fields. Every document contains about how many fields? 35 fields. If any one of the field goes wrong, the entire document gets rejected. You understand? If any one of the field goes wrong, the entire document gets rejected. Suppose if one more field goes wrong, it will be considered equivalent to 2 rejections. You understand? It's not matching with any of the definition that normally exist. See, the normal definition of accuracy is you prepare 100 documents, at least 90 documents should be error-free. That is the meaning of 90% accuracy. Am I right?
Yes.
But now, according to this particular company, you know how they calculate accuracy. First of all, they don't check all the documents. They'll only take a sample, first condition. Your accuracy is calculated based on the sample. If you submit 10,000 documents, they'll only take 10%. What is 10% of 1,000? Sorry, then 10% of the 10,000? 1,000 documents.
1,000.
They randomly pick up 1,000 documents and then thoroughly check each document. All right. And if there are 500 mistakes or 500 errors identified, then 500 documents will be rejected. So what is your accuracy now?
50%.
50%. But what would have been the reality? Reality, the accuracy may be more than 50%. Because same document can have 2 errors. Same document can have 3 errors. A document can have 35 errors. So the 500 errors could have come from just 100 documents possible.
Yes.
Do you understand? That means 900 documents are error-free. But still their calculation wise, your accuracy is how much?
50.
Only 50%. See, why I'm telling this example is not to confuse you, but to, make you understand, the customer requirement is very important. Make you understand, a properly defined metric. The availability of a properly defined metric is very, very important for the success of any project. If the required meaning is different and you understand the same, same thing in some other manner, I'm very sure you are not going to fix any problem. Yes or no?
Yes.
So this is the meaning of a problem well defined is half done. Otherwise, if the beginning is wrong, then everything is wrong. You have an understanding about accuracy and the other person has some other meaning, the other person has one another meaning. Do you think all these people will work as a team and then solve the problem? No. All of them should come to the same level. They must have a proper understanding. So in the point phase, the first and foremost requirement is a pain metric has to be defined. You must have a proper formula and then a unit of measurement. In the example, I said accuracy. Accuracy is measured as a percentage. Right? So that is first thing. And number 2, your problem should be very, very specific. Problem should be very, very specific. If you talk about accuracy, in which particular project you are talking about, and within that particular project, if there are no different groups, are you going to consider the documents produced by all the groups, or are you going to limit your attention only to any particular group within the project? You understand? Let's say there are 1,000 people involved. And these 1,000 people are divided into 4 groups. Group number 1, group number 2, group number 3, group number 4. Then each group will have 250 data processors. Now you can always, select a particular group and then limit your project only to that group. Am I right? Of course, all 4 groups are producing the same kind of documents. But purposely, I don't want to work with all the 4 groups. I wanted to select only one group out of the 4. You know why am I doing like that? Because there the error rate is very high. So you can use tools such as Pareto to make a comparative study. Which group is contributing to more rejections? Is it possible? Which group is contributing to more rejection? Once you do a little analysis, group number 1, group number 2, group number 3, group number 4, and the number of errors in the quality check, you will have some numbers. And whichever group has a higher number, that should be considered for the improvement first. You know why? The what do you call the amount of effort and the considering the amount of effort the improvement will be significant. So for that purpose, we pick up one particular group, and then after picking up that one particular group, I will deep dive, probably dive further. How can I dive further with the same particular group? Let's say group number 2 is our interest right now. All right, because group number 2, the rejection rate is very high. And now I want you to gather the information, the detailed information. Every document will have how many field I told you?
35.
35 field. Now I may ask you to
35.
bring the errors field wise. Do you get my point? Earlier it was group wise. Group number 1, group number 2, group number 3, group number 4. Now that we finalize group number 2, and now let's say there are they made 1,000 errors. Now I want these 1,000 errors to be segregated field wise. Field number 1, how many errors? Field number 2, how many errors? Field number 35, how many errors? Why is this important? You could understand which particular field people are making more errors. Is that logical? The moment I understand field number 28 is the very problematic field, then I will arrange for a meeting, or I will arrange for a training, additional training to help my team thoroughly understand how to handle field number 28. I will bring some visuals, I will prepare some kind of charts and make the information thoroughly available in the charts. Now the issues related to field number 28 will vanish now. Yes or no?
Yes.
Why am I attended to this field number 28 and group number 2 first? Why not others? I know what exactly is the problem. I also get to know what should I do actually to rectify the problem. Now I have taken the first action. Once this is done, then I can move on to the next field in line. Yes or no? Then I move on to the next field in line. So this way, if the problem becomes more specific, it becomes actionable. Yes or no? Simply keeping the scope more wider is a hall full of confusion. Nobody is going to fix anything. So always try to draw boundaries and play within the boundary. And of course, you very well know that whatever you are scoping out, that will become a problem later on, definitely. But then first you solve a specific problem, right? Problem with a limited scope. Then you work with the other areas also. Do you understand what I'm trying to say here? So you can make use of the tool known as Pareto, nothing wrong in it. It says 80-20. 80% of the customer dissatisfaction or 80% of the cost of poor quality are contributed by just 20% of the defects or mistakes. Do you think this logic will be applicable? See, right now the training program, how many people are asking questions, how many people are interacting? Just 20% of the participants, isn't it? 20% of the participants are just observing how this 20% of the people are interacting. But however, in the process, they also learn. So 80-20 rule is applicable in many areas, right? So you can use that rule, and you can use the Pareto to prioritize. And also you can use the Pareto like Veer Raghavan would have taught you. Level 1 Pareto, level 2 Pareto. What is level 1 and level 2? You are dividing the information, into certain categories. Like I was saying, which particular group, and then which particular field. And then within the field, if there is any further subdivision possible, you can divide accordingly. So this is known as stratification. This is known as stratification, stratifying a problem. Right? We just categorize the problem and then pick up a specific category for further analysis and action. So once this understanding is developed, you can proceed and start writing a project charter. You can proceed and start writing a project charter. What are the 6 major elements in a project charter? Business case, problem statement,
Business case, problem statements, goal
Goal
statements,
statements,
statements, timeline, team
timeline,
members.
team members.
resources.
Yeah, exactly. Business case, problem statement, goal statement, scope statement, timeline, team member,
And
plus some additional information like budget, risk involved, whatever you want to add. And then it should be signed
Resource.
by project leader, finance controller, and then the project sponsor. And now what will be the interest of the project sponsor? Suppose if you are the project sponsor, what will be your interest if somebody, submitting a project charter to you?
What is the benefit to the customer?
What
To
is the
reduce,
benefit? First of all, what is
to
the benefit
reduce
to the company?
any kind of defect. Yes.
See,
Company
first thing, suppose,
sponsor.
see, sponsor is a part of the top management. Imagine you are the director in a company, or you are the managing director, or you are the CEO, or you are the boss. If somebody is proposing a project and demanding, let's say, 20 lakhs investment, and now you have to approve the project. Will you just approve it just like that because they are asking 20 lakhs? Will you just approve it? No. You will certainly try to understand what will be the benefit to the company. You very well know they are solving an important problem of your company, important problem of your customer. But still, you will be interested in knowing, if I provide this 20 lakhs, what is that I am going to get back, particularly in terms of financial benefit.
ROI.
ROI, return on
ROI,
investment, right?
yes, return on
That is
investment.
known as business case. Suppose you invest 20 lakhs and then you will know only 2 lakhs will be the saving over a full period of 1 year. Do you think the sponsor will immediately consider the project and then give all
We have
priority?
to consider that what is the short-term benefit as well as that long-term benefit. What
True.
are the direct benefits are there? What are the indirect benefits are
Very good. Fantastic.
And
Very good understanding. You developed
and
very
what
good
are the
understanding.
peoples who are involved there?
So you understand, what kind of problem the team is trying to solve. At the same time, the first priority is financial benefit. And this is true with many companies, right? So financial benefit, 20 lakhs is the, project budget. So if the returns, are projected, let's say more than 650, 60 lakhs, then definitely there is a business case. And anybody can think about investing that 20 lakhs because within 1 year, you are going to get back 3 times the money, 60 lakhs. So there is a financial benefit, direct benefit. There is also non-financial benefit, indirect benefit, or you can call it long-term benefit. Somehow long-term benefits, indirect benefits can also be expressed in dollars. Possible or not? Some effort is needed. That's all. You just have to carefully type down all kind of benefits and then find out a suitable conversion rate, some conversion method, and then you can convert that into rupees or dollars. And now that direct benefit, 50 lakhs, indirect benefit, 25 lakhs. What is the total benefit? 75 lakhs. Or total savings, I would say. Total savings in cost of poor quality is 75 lakhs and the investment is 20 lakhs. So the project looks very attractive right now. Now, this statement really motivates the sponsor to read your project charter completely. Yes or no? So the first component is business case. The first component is business case. And the second, and please note, while talking about the business case, you should talk about the benefits to the company, financial and non-financial. And talking about the problem, talking about the causes is not the right idea. Because what is the heading now? Business case. So don't try to write anything about the problem. Don't try to write anything about the causes. Limit your details only to the benefits to the company. All of you are with me on this? I always, speak mathematically, X, Y, and Z.
Yes.
Y is the problem. X are the causes. Then Z are the benefits. Isn't it? So business
Yes.
case talks about Z, not about Y, not about your X. You don't have to write anything about the pain metric. No, not required. Straight away you talk in terms of the Z. Am I right? Now going to the problem statement. When you go to the problem statement, you must speak everything about the Y. Problem means your metric of pain metric, isn't it? Your pain metric should necessarily participate. In the BPO industry example, the pain metric is the accuracy percentage. Our accuracy is, below 50%. That is the problem. What is the requirement? Against the requirement of minimum 90%. Customer, will make the payment only if the accuracy is above 90%. But where is our accuracy? 50%. And how long this problem exists in your company? Just last month only? Or they say the problem exists for more than 6 months. You should talk about it. Duration of the problem, isn't it? Last 6 months, our accuracy rate is below 50%. Because of which we are not able to claim the payment from the customer. Very, very, the painful for the company. They have been working, but then they are not able to raise the invoice simply because they are not meeting the accuracy requirement of the customer. And how long this is happening? More than 6 months. And which particular project it is happening? You have to tell, isn't it? Company might be running several projects. Maybe project number 4. And suppose within the project number 4, as I mentioned, particularly group number 2. So you should also talk about where exactly the problem is happening, the duration of the problem, where it is happening, right? And then what will be the consequence? If the problem is unattended, again, within another 3 months, the customer will cancel the contract completely. Yes or no? So now you are talking about the problem statement. Clear? But there is no point of writing a big paragraph or, writing an essay. No. Just be very crisp at the same time to the point. Right? 2 to 3 lines, but it should communicate. What are the keywords here? Pain metric, duration of the problem,
Duration of the problem.
where exactly
Where
the
it is
problem is
exact.
happening,
What is the
how
consequence?
long is the problem, how big is the problem, and where exactly the problem is happening, and what could be the consequence. Just write this. And this is enough for a project sponsor. All right. Then you move on to the goal statement. What your goal should be for the pain metric. What is the pain metric? The accuracy percentage. Your accuracy is 50%, and what should be your goal? It should be above 90%.
90.
Because anything below 90 is not going to help the company. It's a clear-cut requirement. Minimum 90% is required, so above 90%, or you can fix 95 also if you think it is achievable. So goal must be SMART. You might have studied, right? What does SMART stand for? Specific,
Measurable.
measurable, achievable,
Achievable, relevant, time bound.
time bound. You know the meaning of it. Make sure you comply to all the 5 principles of setting a SMART goal. And then, but now please note, you have to set a goal for Y, not for Z. Goal is not to, make a saving of 50 lakhs or 75 lakhs. Goal is to make the accuracy above 90%. Clear? So goal should be fixed, set for the Y variable. And nowhere in the project charter, you should talk about the causes. Nowhere in the project charter, you should talk about the causes. Even if you know the causes, please don't talk about it. It's not required. You need to talk only about the problem and the benefit, Y and Z, that's all. And then the scope of the project. Which department, which group, or which specific field, or which particular garment, which particular defect it is, which particular process it is. That is where you should go to the process level. Which particular process means Y equal to f of X. The output from the process is your Y. The output from the process should actually contribute to your CTQ, should actually contribute to your pain metric. Your pain metric is an outcome of the process you are going to address. Do you understand? If I work on the process, my pain metric should actually improve. I should be able to solve the problem. To that level, you must develop your understanding, and that is known as what you call the scope statement. What is the starting point? What is the ending point? What kind of product it is, which department, which product, which defect, and which process. Will you be able to find out answer for all these questions? Which department? Then which product?
Which product?
Then which particular defect? And then finally, which process? Do you understand? What are the four things I was saying? The department, the product, the defect, then
Process.
finally the process. This is called scoping. If the department is known, you don't have to work with other departments. Yes or no? The project is limited only to the accounts department. Let us say your boss advise you to, reduce the payment delays. What is the project now? The project is to reduce the delay in making the payment. If you take too much time to make the payment, some of your suppliers, might go away from you. And finally, it will become a big problem for you. So you wanted to retain them. So you realize that, delaying the payment might make them, leave even the business contract. So your boss advised you to reduce the lead time for the payment. You understand? Now, what is the pain metric? Now, what is the pain metric? Come on.
Check with finance.
What is the pain metric now?
50% quality.
Come again?
50% quality is payment.
50% quality. No, you are talking about the BPO industry. Now I
Yes.
keep on changing the discussion. You need to follow me. Now the last one I'm saying is your boss has advised to reduce the payment delay. Many of your suppliers are sending emails saying that you are taking too much time to make the payment. We are supplying the product, we are releasing the invoice, but you are not making any payment. Now what is the metric you need to improve now?
That lead time delay, lead time to
Delay.
On time payment.
It's a delay.
On time
So
payment.
all of you are correct. So many words are coming, right? Pick up the
Yes.
right suggestion. Maybe the payment lead time,
lead time.
right?
Mhm.
So, but then you have to define it. Payment lead time. What is payment lead time? Can somebody define now? What is payment lead time?
Time taken to
take the payment
Yeah,
after
time
receiving
taken
the
for payment.
Time taken to make the payment. Very good.
Yeah.
And what is the starting point?
from the date of
Receiving of the
invoice.
material.
Once
Receiving
you
of the
receive an
invoice.
item.
Receiving of
From
the
the date of receipt
material
of
or
the
receiving
invoice.
of the invoice or
Invoice.
receiving both?
From that day.
receiving
From
the
that day,
invoice.
that may be 30
From the
days,
date of
45
receipt
days,
of the
whatever
invoice will
predefined,
take
you have to fulfill that.
If the material is received and invoice is not raised, will you be able to make the payment?
No.
No.
No,
Receiving of
The
invoice
date
is
So
of receipt
receiving
of
of
the
invoice.
invoice.
So receipt of invoice is the starting point.
Yeah,
Then end point, payment is made and communication is sent to the supplier.
right.
The moment you send a communication to the supplier, your bill has been processed and payment is released. Here is the reference number. Yes. Do you understand the starting point and ending point?
Yeah.
All right.
Yes.
And now, is that in your project, all the suppliers are in the scope of your project? Or would you like to limit it only to your specific department bills?
A specific department bills.
Yeah, because your company might be receiving thousands of invoices. And you are supposed to handle the invoices related to your department. Yes or no?
Yes.
And also over and above, for this particular project, within your department, there can be 10 different products. There can be 10 different products. And invoices might come for all 10 products. Do you really wanted to speed up the payment for all 10 products? Or only for the critical product, which your boss is currently concerned about?
Specific product only.
The specific product my boss is concerned about. It is always, the more the time your organization, your supplier gives for making the payment, the better it is. But however, for a particular product, the scenario is quite opposite. You wanted to pay fast, and so that because the supplier is probably one of the important supplier of important raw material, maybe. So you wanted to really work on that particular supplier only. So can you see some scoping happening here? You're not really worried about all the supplier, but you are worried about a supplier of a particular raw material. So this scoping is very, very important. And now starting point is clear, ending point is clear. That means the process is clear. Now you also think about what's happening in between. First step is the supplier raises the invoice. Last step is payment is made. In between, what happens? Too many approvals. Too many approvals. And now why too many approvals? Can you do something to reduce the approval time, or can you reduce the number of stages of the approval? All these things, you can think about it in the analysis phase and then the solution phase. But right now the problem is understood. Scoping is also clear. And now you move on to the timeline. To solve this project, what could be, an appropriate timeline? Is it 3 months job or a 6 months job? And define how much time, measure how much time, analyze and think. Likewise, you break it down. Now you have the timeline. And then pick up the team members. You are there as a project leader, and you have proactively trained your colleagues also on these kind of improvement methodologies. So you have some yellow belts and green belts available. So involve them, preferably you involve them as project team members, particularly people who are connected to the process. You know the starting point and ending point of the process. All the people coming into the picture between the starting point and ending point, will you be able to visualize?
Yes.
They all should be part of your project. Maybe some of them are project leaders, some of them are team members. Some of them are used as subject matter experts. We don't know. So all that you have to form, and now you have a nice project charter ready. And now you can bring your Pareto, whatever data, some additional graphs. So make it very attractive so that the sponsor can quickly understand. And then with the signature of the finance controller, yourself and everything, yes, he will be motivated to give a go-ahead signal. He will also sign, and that's an indication of completion of defined phase. So the output of the defined phase is an approved project charter. What is the outcome or output of a defined phase or deliverable, we say? The main deliverable of the defined phase is approved project charter. And so that also indicates the start of measure phase. Right? And I think now you all have the proper understanding about defined phase. And maybe the more the number of the tools you learn about the defined phase, then more will be your confidence. You can bring a Gantt chart, or you can also bring a kind of process flow chart. All that will help the sponsor to quickly grab the point. Oh, they are planning the project for 6 months. How can he understand? Just by looking at your Gantt chart. Right? And then the process also you indicate in the form of a flow chart. Oh, he is talking about the payment processing for a particular department, for a particular product, for a particular supplier. And see, one more way of scoping is only invoices having a bill value of more than 50,000 rupees is considered under the project. Invoices less than 50,000, that's not going to be a big problem. But all big high value invoices, there is the real problem. Do you understand? So these are the criterias, or based on the scenarios you draw the boundaries for your project. We call it in scope and then out scope. All invoices, invoices having a value of 50,000 and above are in the scope of the project. Invoices having a value of less than 50,000 are out of scope. Correct? So you need to understand the ground reality. The facts and figures have to be understood, and then accordingly project charter is created. Now we will move on to the next phase. What is the next phase? Measure phase. Now the objective of the measure phase is to accurately measure the baseline performance. Accurately measure the baseline performance. So what is the baseline performance? The ground reality. Suppose if you are working on a project to reduce the rejection rate, the project charter says the rejection rate is 5%. The project charter says the rejection rate is 5%. But your project team actually collected data for 30 days time period. And according to the 30 days study, according to the data, it says that the rejection rate is 8.5%. Now tell me, what is your rejection rate? Will you still proceed with 5%, or would you like to update it to 8.5%?
5%.
Come on, tell me.
8.5%.
5 or 8.5? Which one to proceed now?
8.5.
8 point. Because that comes with an evidence of data. And you studied 30 days. 30 days is a sufficient number of time. No, 1 full month you studied. And on an average, the rejection is 8.5%. Within 1 month, there are 30 days. And each day there are 3 shifts. So 30 into 3, near about 90 shifts data available. And according to the 90 shift data, and the rejection rate is 8.5%. Now your project charter must be updated. You must update your project charter. All your calculations, cost of poor quality, financial benefit, everything might get updated now. All these things will happen if you start collecting the data, if you start, understanding the reality. Do you understand, all of you? The problem is getting validated, number one. Yes, there is a real problem. And the intensity of the problem is calculated accurately. Earlier, then why did you write 5%? It is in the record. Or people have orally communicated to you. Some information somewhere was available, you picked it up. But then you very well know, as a Six Sigma expert, you very well know accuracy is very important. You can't go blindly, isn't it? I can't simply close my eye and then drive my car. I don't know whether I will reach the destination or not. So I know my responsibility to verify everything before acting, isn't it? So I collected data for 1 month, and then, I understand the rejection is much more than the expected or, the so far understood value of 5%. So I rewrite the problem statement. I rewrite the problem statement, I recalculate the benefits, I recalculate the budget, and a lot of updation happens. And it may even go to the extent of getting it, approved by the sponsor again. Agreed, all of you? And then
Just a
once
small
the
query in this.
yes.
Sorry. What if we, during the project charter, the rejection data was 5%, and later on, after releasing the project charter, and when I collect the data, for the period of 30 days, the rejection rate went up to 8.5%. What if in this case, do we need to still revise the project charter, or should we go with the target of 5%?
Now, this is what exactly I also explained. 5%, increase to 8.5%. So I'm suggesting you to modify your project charter. And you say that, the rejection is 8.5% because it keeps on increasing. It was staying at 5%, according to the past data. But however, we cannot say whatever recorded is accurate. We cannot say, there is no guarantee. Right? Somewhere it is recorded, and then, the information is made available. But from 5%, if it suddenly shooted up to 8.5%, then you may have to highlight. No, you have to say, yes, last 30 days period, the rejection rate is averaging around 8.5%, and accordingly you can remodify. Yes, Samya madam, what is your question?
Sir, maybe after the end of measure phase, if the rejection rate becomes, instead of 8.5, it becomes 2%. And if the problem becomes insignificant, then should we stop the project at measure phase?
No. See, if it happens in the beginning stage of the measure phase, then probably there is a chance to reconsider whether to continue or stop the project, because there is no
Stop the
problem at
project.
all. People are only saying that there is a problem, but in reality there is no problem. Then you realize people don't know how to measure. Then you realize your people don't know what is good and what is bad. The proper definition is not available. And people are just like that, classifying all the good products as bad products and projecting and giving a wrong projection of rejection rate of 5%. But actually, even those rejected items are good products. That is the point, isn't it? So you just have to now prove that your people do not have a valid measurement system. And maybe some improvement with regard to the measurement system is your project. That's all. Your project is to validate the measurement system and improve the measurement system. That's all. So good is always classified as good and bad is always classified as bad. All right. But once this is validated and then data also confirms in the measure phase, see, just like that, it can't come down to 2%. It's not possible. It's not possible, but definitely, if you see somewhere, if you give any room for a factor to come in, then only it can come. Isn't it? In the earlier conversation, I was saying that, the information, what is available is captured just like that. So there is a chance that it can go wrong. But the 30 days data is collected by us, isn't it?
That is
How
due
can it
to-
suddenly, change? So it is not possible. And that too, from 8.5 to 2 is a significant drop.
No. That is during the measurement phase only, we understand that it is not 5%, but it is 2%.
In that case, yeah. In that case, you may have to reverse the project. And then the whole idea of the project will change now. The whole idea of the project will become improving the measurement system. Why people are doing like this? Right? Is it the problem with the measuring instrument, or problem with the assessor, problem with the quality checker, or is there a problem with the instruction given to them? You have to start investigating in that direction. And then, the outcome is a validated measurement system. Afterwards, no, this kind of mismatches are not possible. All right. So the main outcome of the measure phase is accurate measure of the baseline. Accurate. Notice the word accurate. What is the meaning of accurate or accuracy? The measured value and the true value are same. Correct? The measured value. You measured the rejection, and there is an actual rejection. Your calculated rejection rate is 8.5%. Actual rejection also 8.5%. And now your measurement is accurate. There is no difference between measured value and the true value. Let us say you write the exam. You wrote the exam for exactly 70%. But I am giving you only, 60% mark. You understand? And now can you see a bias? You very well know that you have answered 70% of the questions correctly. Your mark should have been how much? 70. The true value is known. But me as a teacher, how many marks I am awarding you? Only 60. The
60.
measured value is 60. But the true value is 70. Now the difference is known as bias. The difference between true value and the measured value is known as bias. The teacher is biased. He gives 10 marks less. Similarly, your measurement system can also be biased. If the measurement system is biased, immediately your readings will become inaccurate. Yes or no? And the guideline for the bias is it should be less than 10%. It should be less than 10%. Less than 10% of the range of tolerance given by the customer. Less than 10% of the range of tolerance given by the customer. All of you, do you understand what is range of tolerance? Upper limit and lower limit. Customer always give upper limit and lower limit, isn't it? Let us say the customer requirement is thickness must be 100 mm plus or minus 0.5. Now, what is the upper specification limit?
100.5,
Then lower specification limit?
99.5,
Now, what is the range? What is the tolerance range? 100.5 right side, 99.5 left side. Now, what is the value in between? What is the length of the line between USL and LSL?
1
1 mm. Now, 10% of 1 mm is how much?
0.1.
0.1.
Ye-
So, 0.1 mm should be the maximum bias in your reading. Otherwise, your measurement system is unfit for data collection. If you have a measurement system and then for the known tolerance or the known range, there has to be some limit, right? Upper value and lower value. The difference between the upper and lower is the range. Considering the range, bias must be less than 10%. This is how you can validate your measurement system. If this bias is less than 10%, then measurement system is considered acceptable. Otherwise, unacceptable. Please note, if you really wanted to control the bias, then you must first try to understand how the bias is getting populated. Yes or no? How the bias is getting populated. And so we will talk in detail about that. So that is one thing. So the estimating the bias, I mean the estimating the inaccuracy. Estimating the inaccuracy. And there is one more thing. Estimating the inconsistency. That is also important. Inaccuracy is one thing. Another one is inconsistency. See, so I'll talk in detail about both of this. You must estimate. Finally, the measurement error, nothing but the bias, should be less than 10%. Whether it is because of the inconsistency or because of the inaccuracy, whatever. Ultimately, the bias must be less than 10%. Then measurement system is validated. Once measurement system is validated, you can use the measurement system for data collection. When it comes to data collection, people easily get confused with the sample size. Always they get confused with the sample size. And my suggestion to all the belts here is, first, make a proper decision about the data collection period. Make a proper decision about the data collection period. 30 days of data is a sufficient period. All of you agree with me? Studying your manufacturing process for 30 days. Can it not capture all the facts? So 30 days is a good period, right? In fact, long enough. Suppose if 30 days are not available, only 10 days are available, then what will happen? Your data collection period will reduce to 10 days. No other option. Clear? And now once you are freezed with 10 days, now you think about data collection frequency. Data collection period afterwards, data collection frequency. How frequently you want to collect data? Do you want to collect data every single day? Or do you want to collect data every single shift? Or do you want to collect every single hour? Will you be able to answer all these questions? You can make a decision, isn't it? Because you have a proper understanding of the problem in defined phase. Let's say you have a problem about your kids. You suddenly started doubting whether your kids are going to the school or going somewhere. Maybe your matured kids, now they are not going to school, they are going to college. Now you have a doubt. Are they going to the college or they are going somewhere? Now, how frequently you want to check? Weekly once
Yeah.
or daily? Which is better?
Daily is better.
Daily.
Daily is better. But if you call hourly, then the teacher will start disconnecting your call, right? So daily is better. So once you have a proper understanding of the problem, deciding on the sampling frequency is not a big deal. Right? Collecting the sample daily, every single day, every single shift, sample must be collected. All of you agree with me?
Yeah.
Both the first shift, second shift, and also night shift. You know, it's the same setup, all shifts are running in the same fashion, but still you want to collect data from every single shift. Looks logical, right? Your idea. And now a shift means, let's say 8 hours. Do you want to just collect sample once during the 8 hours time? Or do you want to collect the data, sample every single hour or every 2 hours? Suppose if you are into food manufacturing, many of you, I know you are into some food manufacturing related, right? And now tell me a good food item. Laddu
Biscuits.
or jangri or some milk sweet, whatever.
Cadbury,
Imagine you
Cadbury
have,
chocolate.
okay, Cadbury's chocolate. So imagine you have a big line which is producing chocolates. And what will be the production capacity? 1 hour, how many chocolates? 1 hour,
Let's
how many
take like
chocolates you might produce?
let's take 10,000.
10,000 chocolates every 1 hour. Now the situation is thoroughly understood. You have 10 days time. And every single day you are going to take sample. Every single shift you are going to take sample. And every 1 hour, 10,000 chocolates are getting produced. Now tell me what should be your sampling frequency? Hourly once? Hourly once. Why you have decided to go for hourly? Because 10,000 is such a huge number, isn't it? If that sample is bad, all 10,000 pieces will get rejected. In fact, you might even would like to take a sample 30 minutes once. Because you can't see, the situation is very sensitive. If the sample says something, shows something wrong, then all 10,000 chocolates have to be scrapped. Even if each chocolate is 10 rupees, then you have to burn 1 lakh.
Yes.
So instead of that, can I increase the sampling frequency? Can I take it once in 30 minutes?
Yeah.
The risk is going down. Can you see that?
Yes.
Yeah.
Yes.
This is how you must drill down when you decide about data collection. Now, finally, once you are about to pick up the samples, now comes the question of sample size. All of it, do you understand? Now,
Yeah.
how many chocolates you would like to pick up? Each chocolate is going to be 10 rupees. Tell me now. You are going to judge about 10,000 chocolates. Now, how many chocolates you would like to check? 1 or more than 1?
I would like to go with 10.
Very good. 10 is a good number. 10 is a very good number, isn't it? 10 samples indicating a problem is a super confirmation that all 10,000 chocolates, there is something wrong. Yes or no?
Yes.
How come a random selection of 10 chocolates all going wrong can happen? It simply confirms that all 10,000 are wrong. Yes or no? You can immediately stop the line You can reject all the units produced and then, look for the root cause. What went wrong? Is there somewhere anything leaking? Somewhere any setup got changed? You have to start thinking in that direction. All of you, do you understand? This is known as data collection plan. All of you, please note, whatever the conclusion you make with the 10 chocolate, the same will be the conclusion with the 5 chocolates. How many of you agree with me? How many of you agree with me?
True.
I selected 10 chocolates and I saw a problem in all 10. What would have happened if you have selected only 5?
Same
All
result.
five.
It's the same.
So, your sample, see, once you have a proper data collection plan, even lesser number of samples can indicate the reality. Even a lesser number, but you can easily afford a sample size of 10, yes or no?
Yes.
So to be on the safer side, you take 10 samples. If you still feel, doubtful, take 15 samples. Go as high as 25, but not more than that. This is a thumb rule, right? This is a thumb rule, but out of experience, yes, this is arrived. And this will definitely, help you make the right decision. But there are theories available, there are formulas available. At this stage, they are not required. At this stage, they are not required. But avoid taking very few, lesser number of samples. Just taking 1 or 2. So, avoid taking it. Because the risk of your decision going wrong will be very high. All right? Unless and until if one chocolate is 10,000 rupees. If one chocolate itself is 10,000 rupees, then, your company may not like you to, test 10 pieces and 25 pieces, isn't it? Testing itself, you will be burning a few lakh rupees. So that there is a necessity to reduce the sample size. And trust me, a sample size of even 3 or 5 can get you the reality. I'm suggesting you this based on, the statistical concept, particularly based on a statistical theorem known as normal distribution, which you will be, learning slightly at a later stage. Yes, Soumya madam, you have a question.
Sir, actually, we understand this measure point with respect to production data, but let's go back to the example which we discussed about payment lead time. So in most of the cases, this payment data would be available in some SAP or ERP systems where the data is accurately measured already.
Correct.
So what to measure, what factors to measure in measure phase?
Yeah. See, our project is, payment lead time. And you are clearly telling me that, sir, payment lead time is recorded accurately. Then you take all the data, that's all.
Okay, so nothing more to do in measure
No
phase.
sampling, there is no challenge of sampling there. And in a day, you handle about, 30, 40 invoices, all 30, 40 invoices, time is available and 100% of the information is available. And now go for a complete population. Every invoice, because it is recorded anyway. If the wealth of information is available, use everything, because it's not going to take much of your time to just put it in Excel and then do all the analysis. It's very much possible. So you can avoid, see, always, sampling comes only if time and money becomes, unaffordable. Right? Whether either it should be costlier or it should be more laborious, time consuming, tedious, that's the time you should prefer sampling. Otherwise, if everything is available handy, just use it, because that is the information you really want. Why we go for sampling? If I produce 10,000 chocolates every 1 hour, do you think checking each and every chocolate is a good idea?
No.
No.
So it's tedious, at the same time, time consuming, and there are many other consequences. So sampling is the only way. So I'm deciding to go for the sampling. But if you have, let's say, a kind of online live inspection of the chocolates, using which every single chocolate can be inspected virtually.
Mm.
No quality checkers required, but you have some cameras, you have some,
Optical
kind
inspection.
of electronic instruments which can capture whether all the chocolates, goes with the proper wrappers, all the chocolates goes with proper formula. If any particular ingredient is more than the permissible level, it detects automatically somehow. Now information is available. Why do you need sampling? Yes or no?
So if the data is available in a reliable form, we can just populate and come to an understanding of what is the actual problem.
That is the ultimate purpose. With the sample also, we are trying to do that only.
Correct.
Only because it is time consuming, I am not checking everything.
Mm.
Otherwise, my requirement is not just to understand the sample. My requirement is understand the population.
Correct.
And you are saying that, sir, population data is available. That's a great scenario. There are 50 participants here. Now I don't mind, going through the mark of each and every student here. Because I'm really interested about, seeing that everybody is, passing out. And now my idea of just looking at 2-3 faces or just looking at 2-3 students is really, a bad idea. My entire population itself is 50. So population is, easily inspectable. Then also I avoid sampling. My population itself is small.
Sure.
So I'll go for a 100% inspection. Nothing wrong in it. But only if challenges exist where I cannot really understand the characteristics of my population. What is, what percentage of my population is good, what percentage of population is bad. I really don't know because my population is so big. In that case only I'll go for sampling. Again, in the sampling, data collection period, data collection frequency, then finally comes sample size. Clear, all of you? But please note, the understanding of the characteristics you want to measure is very, very important. You should be able to write down the definition. When I say accuracy percentage, I have to write a 2-line definition. Then only all my team will come to the common understanding. If there are 10 members in a project team and 10 members understand the meaning of accuracy in 10 different ways, who think all these 10 fellows will solve the problem? They will kill everyone around them, isn't it? So that should not be the case. So the tool that can help you to avoid this scenario is, or avoid this problem is, operational definition. A clear and concise statement about the metric to be observed or the characteristics to be observed and measured. If I want you to measure your body temperature, then I have to give a clear-cut instruction, isn't it? How I should measure the body temperature. Can I use a thermometer, ordinary thermometer, or nowadays, people have come up with the latest kind of thermometer, right? Without even touching you, they measure your body temperature. Even to use that, some instructions are required. Yes or no? At what distance I should check? Otherwise, what will happen, I will get one reading and you will get other reading, then the other person will get other reading, and that doesn't serve the... How, see, things can go wrong very easily, isn't it? Definitely there will be, many such members like him in any project team. So you have to be extremely careful, and there will be people, maybe even unknowingly they could commit all these mistakes. So you have to be very, very, consciously take steps. That's why, very important to write down the definition. This is the characteristics, and this is how it must be measured. You clearly tell them how they should hold the product, and how they should hold the measuring instrument, and how many readings are required, and whether he should be in a sitting posture or he should be in a standing posture. Everything has to be written down clearly. Don't consider anything granted. If you think that they know everything, they will exactly do the opposite. So
Should we
operational
consider
definition.
doing MSA at this phase, sir?
Yeah. See, this operational definition is a part of your measurement system. Slowly, I'm coming to that. One thing is data collection plan. You all know, see, data collection plan, I told you, data collection period, data collection frequency, sample size. And then I now talked about operational definition. All right. Then the next step is, MSA, measurement system analysis. Even before going to the MSA, I would like to talk to you about one more important concept, the data types. There are two types of data. One is continuous data, other one is discrete data. All measurable characteristics, anything that you can measure with some physical unit of measurement is known as a continuous data. So what is continuous data? Any characteristics that you can measure accurately with some physical unit of measurement is known as a continuous data. Yes or no? The variable is known as continuous variable and the data is known as continuous data. Say for example, room temperature. Tell me room temperature, will you be able to measure? What is the unit of measurement?
Degree
Centigrade or
Degree
Fahrenheit.
centigrade or degree Celsius. So it definitely it is falling under continuous data. The temperature is a continuous variable, so data generated is a continuous data. Now I want to know the effectiveness of the training program. I want to know the effectiveness of the training program. Do I have any measuring instrument?
No.
Is there any unit of measurement?
No.
No physical unit of measurement, only some percentage is possible finally. I will simply ask you, how good is the training program? Can you rate it on a 10-point scale? Then suppose if really the training effectiveness is exactly 8, do you think all of you will give 8? Some of you will give 10. Some of you can give 4. Some of you can give 7. Now, the possibility of the bias is very, very high. Yes or no? And some of you might not have attended the session, but still, having seen a feedback form, he will also open and then fill up. Yes or no? And he is in a very bad mood and then he will give 0. Now, possibilities of your data becoming inaccurate is very, very high if measurability is weaker. If you deal with the characteristics where measurability is weaker, isn't it? So such data are known as attribute data or discrete data. Suppose you work with such data, you should know its limitation. And then after receiving the feedback from 50 participants, now I will find out how many people rated 10, how many people rated 9, how many rated 8. This is the only way I can calculate. Out of 50 people, 30 people rated our program 10. Now what is the percentage? 60% of the people rated as 10. That means remaining 40% rated as either 9 or below. This is the conclusion I can come, and I only get a percentage as the estimate. Do you understand? Earlier, exact unit of measurement, but now it is only a countable information. 30 people gave 10. 30 is a counted number, yes or no? Measurable numbers are continuous data. Countable numbers are discrete data. Do you understand? How many people are on the camera right now, including me? How many people are on the camera right now?
9.
1, 2, 3, 7, 8, 9. Okay. 9 people out of the total. Total is very less today. I don't know, 28. So 9 out of 28, isn't it? So this is what kind of data? Is it continuous or discrete? 9.
Discrete.
Continuous.
Right. Not continuous. It might
It's
change.
continuous.
Right.
This is countable information. We just counted, isn't it? To say continuous, it should be measurable. See, I know, I understand you counted accurately, but that's not the complete definition of discrete data. Measurable characteristics are continuous, and then the countable characteristics are discrete. See why we call it discrete? No, the outcome is always a whole number. The outcome is always a whole number. It is never in decimals. You can't say, sir, 8.5 people are on the camera. No, only 8. Isn't it? So decimals are not possible. So always, since only whole numbers are possible, sometimes, your data will get rounded off and all those things can happen. So continuous data are preferred over discrete data. If you are really concerned about accuracy, you must prefer to work with continuous data. Yes, sir. Surface finish, tell me, surface finish, continuous data or discrete data? Or surface finish
Continuous
measured?
Discrete data.
No, surface finish,
Continuous
if you
data.
do a visual inspection, it is discrete.
We have measuring tools for measuring the surface roughness.
If you have a measuring instrument in your workplace, then for you, surface finish is continuous variable. Continuous data. Pressure, continuous data. Temperature, velocity, your body weight, your sugar level, your BP level, all of them are continuous data. Yes or no? A number of parts rejected, shift wise. Number of parts rejected is discrete data. Number of students in a classroom is discrete data. Isn't it? Number of machines, discrete data. And the customer satisfaction score, discrete data. Customer satisfaction survey, any survey you conduct, you generate only discrete data. All of you are with me on this? So now we move on to the next topic. What is the next topic? Measurement system analysis. Measurement system analysis means checking or assessing whether my measurement system is good enough or not. Checking whether my measurement system is good enough. Good enough in the sense, whether, how accurate it is. So, see, error in every single time we collect the data, error will accumulate. Every single time we collect the data, error will accumulate. And now there are two sources of error. One is the error due to inconsistency in the measurement system. The error due to inconsistency in the measurement system. Another source is the bias in your measurement system. You understand? One is the inconsistency in your measurement system. The other one is the error or the bias in your measurement system. Now, can all of you look at your watch and tell me what is the time right now?
10:07.
Yeah, please type the time in the chat box, all of you. Please type it in the chat box. I got 3 readings, 4 reading. Now tell me, is that all the readings are exactly same? Why somebody, 8:48 in Dubai. Okay, yes. Okay, except Vyas, all others in India, all of them got the same reading. Can you see the same reading here? But Krishnan is saying 10:18. There's a big problem with your watch. 10:8, and somebody is saying 10.08, and somebody is saying 10.8. There is a difference there also. So that's why operation definition is very, very important. Similar to the scenario of my computer video, isn't it? So 10.08. What is 10.08? 10 o'clock? 8 minutes. All right. Can you see consistency in the reading? If assuming all of you have typed 10.08, can you see consistency in the reading? Yes or no?
Somewhat it is consistent. Not
except
accurately,
few,
but
because the
somewhat
Dubai
it is.
case and then few others who don't know, they just typed 10.8. 10.8 is wrong. 10.08 is the correct, right? Otherwise, there is a perfect consistency. If there is no consistency in the readings, why am I expecting consistency here? Because for everyone, the time is same. Provided all of you in India, The time is same. If the
To
reading,
get the accurate data.
actual reading is same, then your measured reading should also be same. If they are not same among different measurement system, the inconsistency is given a special name, reproducibility error. All of you, do you understand?
Yes.
If all of you have a similar measurement system and you are measuring the same characteristics, but then your readings are not agreeing to each other, this is a form of inconsistency. This form of inconsistency is known as reproducibility error. Clear, all of you? Suppose, see, if you have multiple measurement system and not agreeing to each other, what is the name of the error? Reproducibility error. Suppose you have only one measurement system. You are the only person collecting data, right? I just, show you a product. Let's say I have the, cap of my water bottle. I want you to measure the diameter of this water bottle. And now there is an outer diameter, there is an inner diameter. Sir, no? There is an outer dia, there is an inner dia. So now I have to give you a proper operational definition. And now you have some kind of vernier caliper in your hand. Now you have to use the vernier caliper to measure the outer diameter. I will ask you to measure the outer diameter 10 times. But how many parts I gave you? Just only one part. But you are asked to measure the diameter 10 times. This is called replication. We are replicating your reading. I am asking you to replicate the reading. But when you actually measure 10 times, you end up producing 10 different readings. Is it not an error?
It is.
Yes.
This form of error is known as repeatability error. This form of error is known as repeatability error. The earlier form is different. Now the new format we are talking. The earlier form was disagreement between multiple measurement system. Now disagreement within a single measurement system. So what is a measurement system? The instrument, the operator, the product, and the characteristics, and the instruction, the operational definition, the environment, all of them together is known as measurement system. Do you understand? So, if you have just one measurement system, but still you produce different readings while measuring the same thing, then the error committed is known as repeatability error. All of you are with me on this? One is reproducibility error. The other one is repeatability error. The summation of these two errors should be less than 10%. The summation of these two errors should be less than 10%. Repeatability error plus reproducibility error. First of all, the repeatability error plus reproducibility error is known as precision error. Summation of repeatability error and reproducibility error is known as precision error. Now this precision error should be compared against the tolerance range provided by the customer. You remember earlier I told you tolerance range 100 plus or minus 0.5, 100.5, 99.5, and so the range is 1 mm. So denominator is range of tolerance. Numerator is precision error. This is a ratio. This ratio, to get it in percentage, you can multiply by 100. So precision error divided by range of tolerance is known as gauge R&R. You know what is the name?
Sir, come again.
Gauge R&R. I will just, I will type it for you.
Sir, you said precision error by range of tolerance, right?
Yeah, gauge R&R. Can you see my whiteboard?
Yes.
Precision error divided by
Range of tolerance.
The range of tolerance, and you also multiply this value by 100.
100. Okay. Into
This
100.
is known as gauge R&R, and this gauge R&R, if it is less than 10%, the measurement system is acceptable. If the gauge R&R is between, how to say? Okay, is in the order of, where is it? Okay, I'll write like this, 10 to 30%. Then the measurement system is conditionally acceptable. But if the gauge R&R is more than 30%, then the measurement system is unacceptable. All of you understand? Please note, if the customer has given you a liberal range of tolerance, if the customer has given you a very liberal range of tolerance, then only second condition come into picture. You know what is the second condition? Gauge R&R 10 to 30%. In all other scenario, only the first rule is applicable. What is first rule? Gauge R&R should be less than 10%.
Less than 10%.
All right. So hope all of you are clear with the gauge R&R rule. All right.
Sir, can you just once again repeat this repeatability error and reproducibility error?
I will certainly. I will do a small exercise with all of you today. Is that okay? We go up to 10:30 today?
Yeah, yeah,
Another
sure.
13 minutes. Yeah, right.
Sure.
Yeah, okay,
Yeah.
okay, sir.
Yeah. So I just, I'll show you a small demo also. So before that, let me also talk to you about the another metric, bias. Please, all of you note, first you should perform the gauge R&R study. First, you should perform gauge R&R study. Ensure gauge R&R is less than 10%. Then only you go for study about the bias. All of you are with me on this? So what is a bias? Bias is the difference between the observed value and the true value. Bias is the difference between observed value and the true value. Again, how do we measure bias? We measure bias as a percentage, because the difference between, I write measured value, okay, difference between the measured value and the true value divided by, again, the range of tolerance, multiplied by 100. Do you understand, all of you? Difference between measured value and the true value, we divide that by, again, the range of tolerance, and then we multiply by 100. So that will be the value of bias. But bias expressed as a percentage of the tolerance. All of you are with me on this? Okay. Who is raising the hand? You want to ask the question, Amatul?
Sir, whenever you are saying something, there is constantly some noise in the background, because of which your definitions which are there, which you are explaining, they are not sometimes clear.
Is it some noise is coming from my side?
No, not you exactly, but I can hear that.
Okay, some others are. Okay. But I feel everybody, I see everybody staying muted. Okay. All right. Anyway, so we are talking about important topic now. We understood about gauge R&R. All of you are right? Then now we are talking about bias, and bias is also expressed as a percentage. Just to help you understand the bias, Imagine the right time right now, the correct time right now is 10:20. I have, the mobile phone showing 10:20. Suppose you have a watch and assuming 10:20 is the correct time and your watch is saying 10:25. Can you see a bias here? Measured value is 10:25, but the true value is 10:20. Now there is a bias of 5 minutes. This bias is positive bias. All of you are with me? This is positive bias. Suppose if the true time is 10:20 and your watch shows 10:50, now it is a negative bias. All your readings are 5 minutes less. You need to know whether the bias is positive or negative. And most important, bias must be stable. Most important, bias must be stable. You know why? If it is stable, you can eliminate the bias. Do you understand, all of you? Suppose imagine your watch always runs 5 minutes faster and your watch shows 10:25. Now, what is the time, correct time right now? Your watch always runs 5 minutes faster and it shows 10:25. Now, what is the correct time?
10:20.
10:20.
Oh, even with an instrument having some bias, you are still able to get the true value. This is known as data calibration. This is known as data calibration. In order to calibrate any data, you should know whether the bias is positive or negative. You should know whether the bias is positive or negative. But most importantly, bias must be stable. Most importantly, bias must be stable. Now, the solution to the problem is calibrating the data. With the positive bias, you subtract the data. With the negative bias, you add the data, isn't it? If your watch is always running 5 minutes faster, what kind of bias you are experiencing?
Positive.
So all the readings coming from your watch must be subtracted by 5 minutes. Then what will happen? The readings will be true. Suppose if the bias is not stable, it is very dynamic. You realize your watch requires some attention. Yes or no?
Yes.
You realize your watch requires attention, so you go to the service center. The battery is now getting changed. Some kind of, all the cleaning, changing of some worn out parts, some lubrication, all are done. This is known as instrument calibration. This is known as instrument calibration. Why are we calibrating? We are
To get the
eliminating.
accurate result.
We are eliminating the bias, so we don't have to calibrate the data. All of you understand? So, see, please note, before coming to the bias, you have another responsibility. You know what is that? Controlling the gauge. After that, come here. Controlling the gauge R&R. Gauge R&R, no, you must conduct first. If gauge R&R is brought below 10%, then you conduct bias. Otherwise, it will be a situation similar to my computers. You might think that there is a problem with the instrument, but actually not. So that should not be the case, right? Gauge R&R study, you are happy with the gauge R&R, now conduct the bias study. And data calibration you don't want to do, then instrument must be calibrated. Now your watch is fully ready. Now you are using the watch you have used the watch for 6 months, and again the same problem happened. Now you realize another thing, calibration frequency. Because once in 6 months, your watch battery must be changed. Once in 6 months, your watch must be serviced. Proper calibration frequency and calibration procedure should be known to you to eliminate the bias. Otherwise, bias will, definitely populate every single time you use the data. Use the measuring instrument. If the bias populate, it's not a problem, but it should be a stable bias. All of you understand? But if the bias is populating in a highly dynamic manner, then you have no other option except to increase the calibration frequency. And over and above, you now understood that your watch, your costlier watch, requires a lot of attention. So you will give the watch the enough care it deserves. Yes or no? If your watch is 5 lakh rupee, can you throw it onto any surface? No. You will allot a specific place. Yes or no? Probably you will put it in a proper box and then keep it in an air-conditioned room where kids are not allowed and so many things. The same care is required for every measuring instrument also. Otherwise, all the theories, will fail. In spite of all the calibration and everything, still your, instruments can give readings with error. All of you are with me on this? Clear now?
Yes.
Very good. And now we have got a few more minutes, 4 more minutes. We'll do a small exercise and then wind up the thing. So what I do is, do you feel that you can 100% eliminate the forms of reproducibility and repeatability error? None of you can eliminate. Some variation exists in all process. In this case, the variation is a form of error. We call it measurement error. So some amount of repeatability error, some amount of reproducibility error will definitely exist. All that you can do is you can have a very higher level of control measures and bring the the repeatability error and reproducibility error to a smaller value. You can only control it. You can't eliminate it. That's my point. So you can definitely bring the gauge R&R below 10%, but you can't eliminate gauge R&R. This is called gauge R&R study. Once gauge R&R study is successful, proceed with study of bias. Once bias study is completed, check whether the bias is stable. If the bias is stable, calibrate it. If the bias is stable, calibrate the data. If the bias is unstable, calibrate the measuring instrument. Bias can be eliminated, but the gauge R&R cannot be eliminated completely. All of you understand? What is the way you can eliminate the bias? Calibrating the data or calibrating the measuring instrument, increasing the calibration frequency, proper keeping of the measuring instrument, proper handling and proper maintenance of the measuring instrument. All that can eliminate bias. But even then, gauge R&R will exist. But you have to ensure the gauge R&R is maintained below 10%. How? By training all your people, by giving them proper operational definition. Yes or no? If you do all of this, then the gauge R&R can be limited to less than 10%. And now your data is credible enough for analysis. Clear, all of you?
Yes.
This is another step in the measure phase. Once this is done, you can now proceed and then use the data for calculating any metric that you want to calculate. Whether you are calculating average surface finish, calculate it. It will be correct. Or you are calculating DPMO, it will be correct. Or you are calculating CPCPK, it will be correct. Or you are calculating the yield metric, that will be correct. Whatever you calculate, yes. That means, you get accurate estimate of the baseline. See, baseline can be calculated in terms of DPMO. You remember we discussed about DPMO yesterday, first day itself. DPMO stands for defects
Per million opportunities.
Opportunities.
You can also calculate PPM. PPM means rejected parts per million opportunities. You can also calculate rejection percentage. Rejection percentage 5% means my yield is 95%. Rejection percentage 5 means my yield is 95%. 95% means accepted parts divided by produced parts. Accepted is 95, produced is 100. So what is my yield? 95%. Please note, there is one more type of yield which is known as first pass yield. Right now, what I said, 95 divided by 100, 95 is accepted parts, 100 is total produced. Now, I am asking you, out of the 95 accepted parts, are there any parts reworked? Do you understand my question? Out of 95 parts accepted, leave about the rejected. Within the accepted 95, you realize there are 20 parts which are reworked before accepting. Now, please tell me how many parts are accepted without rework?
75.
75.
Now, the 75 means parts produced without, parts accepted without rework. Divided by total parts produced, 75 by 100. Now, this is 75%. For the same scenario, two types of yield exist. One is traditional yield, which says 95%. Another one is first pass yield, which says 75%. Which is your real performance? 75% is your real performance or 95% is your real performance?
75%.
75.
So try to achieve the first pass yield of 100%, not just yield. If I conduct an examination for 100 students, all 100 students should pass the exam in first attempt. If only 75 students pass in the first attempt, another 10-20 students, they pass in the second attempt. Another 5 students, they pass in the third attempt. I proudly publish an advertisement, 100% pass. My process is not capable of giving 100% result. What is the real capability of my process? Only 75%, yes or no? Because only 75% of my students have passed without arrears. Yes or no? So, what is the capability of your process to produce acceptable parts in the first run itself? That is the real measure of capability. Hereafter, please use the first pass yield and not the traditional yield. Clear, all of you? So these are certain tools which can help you to measure your baseline. What are the tools? First pass yield, traditional yield, DPMO, PPM. There are few other metrics which you will be learning, in the higher belt levels like CP, CPK, PP, PPK, sigma level. And please note, all of them are related to each other. All of them are related to each other. Knowing one, the other one can be derived. So you will definitely develop a higher level of understanding of all these tools as you move up in the Six Sigma ladder. So if some of you are planning for upgrading your belt level, please do not delay. Beyond certain timeline, they will not be able to help you upgrade. You have to rejoin the course completely. And also, we can't teach participants or students with a lot of assumptions. We have to really, be sure that you have the enough basics to explain you the advanced level of the discussion, right? To explain you the advanced level of the concepts and the tools and techniques. So we always, teach the basics and before teaching you the, higher level contents. So definitely in the upcoming sessions, you will understand more and more insights about all of these tools and techniques. I think now you have some clarity about the measure phase. Am I right? Data collection plan, measurement system validation, and then the third step is measuring the baseline. Data collection plan, I told you, data collection period, data collection frequency, and then data sample size, and then data type, and then operational definition. Keep all this, in your background. And then if needed, go for a measurement system validation. Like Soumya madam was saying, sir, everything is recorded accurately. No MSA is required. All are getting recorded accurately in real time, isn't it? You don't have to do any study. But if you are in doubt about the measurement system, perform MSA. How to perform MSA? First, gauge order study. Then study for the bias. And finally, what is the solution? Calibration, increasing the calibration frequency, and then proper carrying of the measuring instrument during usage, as well as during storage. Now measurement system validation is done. Now you collect data, you calculate first pass yield or traditional yield or DPMO or PPM or CPCPK, PPPK, sigma level or any other metric of your interest. Whatever you want to calculate. That will be the measure of baseline. This indicates the completion of measure phase. Now that you have a baseline, you also know the target. The target you have set in the define phase. Now you know the baseline. Now will you be able to calculate the gap in performance? And now what is the root cause for the gap? That will be discussed tomorrow. All right. So thank you very much allowing me to stretch the session up to this much time. So I really appreciate your cooperation. Thank you very much.
Thank you,
Thank
sir.
you so much.
Thank you,
Thank you, sir.
Thank you. Good night.
Best, yeah.
Good